Hi everyone. So bear with me for a moment here. I promise there's an electronics project hidden in here somewhere, but let's say you want your kitchen trash to have a lid so you don't have to see and smell your garbage when you're not actively engaging with it. That's a common enough preference. And maybe you even have toddlers or pets that you need to keep from digging around in said garbage, so all the more reason to keep it covered. But then you're standing there holding a food wrapper or a banana peel or what have you, and that's where things can get a little sticky, because you don't really want to touch your trash can with your basically clean hands, do you? Right? Right? That's not just me? No, of course it's not just me, because people have invented freestanding trash cans with foot pedals on them, so you can open the lid just by stepping on the pedal. I actually do use such a product in my kitchen for recyclables. But here's the thing. Don't you want your trash can to be near the kitchen sink and all your countertops where you prepare food? Isn't that the logical place for it rather than having to cross back and forth across your kitchen? Of course you do. And that's why when my kitchen was designed in the 1990s, they made provision for the trash to go right here next to the kitchen sink in the form of a trash compactor. Just like the home intercom or the central vacuum, it sounded like a good idea at the time, but now it's the year 2024 and none of those miracles of modern technology really stuck. And so, just like the holes in my walls where the intercom panels used to be, I now have this awkward space that was meant to house my trash collection solution, but into which most modern kitchen trash solutions don't really fit. So the previous occupants put a wine fridge here, but of course that broke not terribly long after I moved in. And like I said, this is really the prime spot in the kitchen for trash. So I was able to get one of those trash can in a drawer things to restore balance and harmony to my kitchen. But now how do I open it without touching it? That's today's project. So this was inspired by a video by Jeff Conte, which I'll link in the description, in which he put together a purely mechanical solution, much like those freestanding trash cans where you stomp on a pedal and it lifts up the lid. And it looks like a really lovely solution, but to construct it, Jeff cut off the end of a serving spoon and welded it to a self-closing hinge. And that's great if you happen to be a machinist, but not all of us have an arc welder in our garage. So after some false starts with some push-push drawer mechanisms from Amazon that quickly broke, I thought to myself, maybe I need to play to my strengths here. I'm better at electronics than I am at mechanisms. Yes, it's overkill, but I'm just trying to get my kitchen back in working order. So let's just motorize it. So I got myself an electrical switch, a foot pedal switch. And let me walk you through how my first attempt at this works. So the foot pedal that drives this is a single pole, single throw switch, which creates some annoyance because in order to be able to drive the motor forward and backwards, I would need a double pole, double throw switch. And so as a consequence of that, this pedal is wired along this multicolored cable into this H-bridge, which allows driving the motor forward and backwards, so it can swap the two positive and negative inputs on the motor. And of course, because I'm doing that, I need logic level voltage. The motor is a 12-volt motor, so I need logic level voltage by way of this regulator in here down to about 5 volts in order to turn it on and off. So all of this electronics is necessary solely because I don't have a double pole, double throw foot pedal. And I didn't see any on AliExpress, although there do exist foot switches, and maybe with some effort I could have gotten that into the current foot pedal. And maybe if any of you play the electric guitar, you'll know what parts to buy for that. But in any event, that all runs a linear actuator with a 15 centimeter stroke, which is about 6 inches. This is about the longest stroke I could get with some decent force behind it. It's about 19 newtons, which is about a little over 4 pounds, which seems to be just enough to open the door. And even then, I had to remove little white plastic things in here that connected to a damper because the manufacturer of this glide system seems to have been concerned about us slamming it shut too hard, and it works in both directions, so it makes it harder to open for that little bit of range where it's in the nearly closed state. And I don't really know why they bothered, because it doesn't glide that smoothly when it's got weight on it. So I'm using a 15-volt power supply that comes in on this cable in to provide the power to both the H-bridge and to the regulator that's dropping it down to 5 volts. This is a 15-volt power supply, even though that's a 12-volt motor, because this H-bridge drops about 2 or 3 volts. But it lasted about a day before it managed to deform its gears enough that it would no longer operate. So I decided to go big or go home. This actuator is actually meant for a power recliner. And it's a good deal more expensive than the one I started with, so I'm a little disappointed. I was really hoping to be able to say that, this relatively inexpensive actuator, linear actuators are fairly expensive compared to just DC motors, but I was hoping to be able to say that this relatively inexpensive actuator would get the job done, but no such luck. And rather than using that single pole switch with all the electronics that added to it in order to be able to reverse direction, I just put a double pole, double throw switch inside a box so that it opens when you depress it and it retracts when you are not depressing it. And I added that metal plate that you see on the bottom because I had to mount this actuator on the underside of the cabinet instead of actually within the cabinet because it's so large. And that's literally all that's going on inside here. It's a double pole, double throw switch. Power and ground coming in that get applied either forward or backwards to the motor. And the linear actuator itself comes with limit switches and diodes built in so that it automatically stops at the end of its range of travel. So I can keep applying the reversing voltage at all times when it's not depressed, and it just stops when it's fully retracted. This is a view from the underside. You can see I improvised with some pipe straps in order to hold it on. So yeah, in the end, I'm not sure this was the best project to try to accomplish with electronics. The revised version with the dual pole switch does eliminate a lot of unnecessary electronics, but it still opens pretty slowly, and then you can't close it again until it's done retracting the actuator. Maybe you could find a faster actuator than I did, and it doesn't necessarily need to be a linear actuator. You could imagine a swinging stick with a roller on the end pushing the drawer open. I think I've seen something like that somewhere, actually. But in any event, I think it would be hard to beat a mechanical solution like we saw in that video that I mentioned at the beginning of this. This project started off with a somewhat grander vision. At first, I was going to try to use a microcontroller to run the driver board, and then I simplified the idea in my head to just the foot pedal as a simple directional switch for that driver board. And then eventually I got annoyed with it wasting, I think, a few milliamps of power just sitting there on standby. So I came up with a way to put a double pole, double throw switch in a plastic box and just bypass all that nonsense. Because you really don't need all those integrated circuits just to open and close a motor. They were unnecessary complexity and unnecessary standby power consumption. So maybe that's a bit of a reminder to all of us to keep things simple. But I think if you're better at electronics than you are at mechanical things, then maybe the simplest solution of all to getting a trash drawer that opens by itself would be to make friends with someone mechanical. Anyway, I hope you enjoyed this video, and if you did, please give it a thumbs up. And tune in next time for another episode of Misadventures in Electronics.